You'll have a few energy questions on the MCAS, and they'll all have to do with something called mechanical energy. And as you recall, there are two parts of kinetic that add together to give you total mechanical energy. First is kinetic energy. Now, do you recall what kinetic means? You should know that. Kinetic means moving. So this is the energy of a moving object, isn't it? Over here, potential energy. Energy can be stored in objects and then used later to move things. So this is stored energy. It's called potential energy. Let's do the calculations first. On your MCAS formula sheet, you'll find the formula for kinetic energy. There it is, a little larger there. It's simple enough, isn't it? This thing is 1,200 kilograms. Put that in for M. It's going at 20 meters per second. Put that there and square it. And of course, don't forget your 0.5. If you multiply them out, you get 240,000 joules. Look here. The unit of measure for energy, kinetic energy, all energies really, is the joule. Now for potential energy, sometimes called gravitational potential energy, we have another simple formula here again on your MCAS formula sheet. You know I don't like the deltas, so I just write it down this way, mgh. And here, this car has driven up onto a small hill, hasn't it? But it's not moving. There's no arrow here. It's not moving. So all it has is potential. And that's easy enough. Mass, again, at 1,200. Remember that the g is a constant 10. Don't forget that. That's your 10. And of course, your height here is 3. And that totals out to a potential energy of 36,000 joules. And then finally, mechanical is just the total of the two. So from our previous slide, we had a kinetic energy of 240,000. Well, I'm sorry, here he's moving also. He's sitting here in the air with potential, and he's moving. So he has both kinds, doesn't he? Yes, so the kinetic we had 2 slides ago, 240,000 joules. Potential, because he's 3 meters in the air, is 36,000. And that totals to a total mechanical energy of 276,000 joules. Easy enough, right? The calculations are easy. If you have to do them in the test, they're easy questions. By the way, here's your video code. I'm putting it in the middle this time. Please write it down later. Please write the video code down. There you go. Okay, now, the classic example is a cart on a cart on this hill. He's going to start here, and his velocity here is 0, isn't it? He has mass of 100. Then he's going to come down to the bottom. Now here he has, oh, by the way, I did mention earlier he had 20 meters of height here, didn't he? Down here he has no height. He definitely has velocity, doesn't he? Then he's going to climb halfway up also. There he's going to have some velocity and some height. Let's see how the energies work. Let's see. Here are your formulas. Now he's on top with no velocity, so I'm not going to bother with that calculation. I know V is 0, so kinetic energy is 0. However, here we have to do a calculation. He has some mass and height, so it's going to be mass of 100 times the 10, which is your g, constant g, and 20 is your height. He has 20,000 joules of potential energy, and of course our total mechanical is 20,000. Then he'll come down the hill. Here he's going, he has 10 meters, he's traveling at 10 meters per second for velocity, but he has no height left, does he? So we have to do a calculation here for kinetic, which is a half times his mass of 100 times his velocity squared. And look at that 20,000. The same number is here. And he has no height, does he? I'm not going to bother with that calculation. I know h is 0. So he has 0 for potential. And we add a total of 20,000. That didn't change, did it? That's called conservation of energy for another video. Now this time he's going to go halfway up. And now he has a velocity of 5. And he has some height. I'm not going to do the calculations. It's going to be, you're going to have half the energy is going to be in kinetic, half in potential, and still adds to 20,000, doesn't it? So it's really important to understand that as objects move up and down hills or climb and fall, kinetic energy is converted to potential and back and forth. One more example of this. Let's say this guy is kicking this ball. He kicks it off the ground. It's going fast in it, isn't it? So he has plenty of kinetic energy. But he has no height yet. As he goes up, say that's halfway, it's half and half, isn't it? The kinetic energy has converted to potential. At the top, we have no more kinetic left. It's no longer moving up or down. We have plenty of potential because of the height. And on the way down, kinetic is transformed to potential as we go. Till down to the bottom, we're back to the same way where we started. It's all kinetic and no potential. So the energy transforms back between kinetic energy and potential energy. And that's important to know. Bye.